Hi, everyone. My name is Nathalie, and I am representing the colony loss monitoring efforts from the United States. I am a postdoctoral associate with University of Maryland, and I work as the research coordinator for the BeeInformed partnership. We are a nonprofit organization whose mission is to improve honeybee health. And we do so through various programs, monitoring honeybee colony health and promoting good management practices. We work with all sides of the industry, from small-scale backyard beekeepers to large-scale commercial operations. We conduct field trials, citizen science monitoring programs, as well as questionnaire-type surveys. One of our earliest research efforts is the Loss and Management Survey, through which we are documenting rates of colony loss experienced by beekeepers year after year. Throughout our programs, we are attempting to follow the strategies of the public health model, meaning we first need to define the issues and monitor them. Then we need to identify what increase or decrease the risk of their occurrence. And when we understand the risk and protective factors, then we can develop prevention strategies. We then need to test their effectiveness. And finally, once they're proven effective, we can promote the adoption of those good practices in the population. So why monitoring colony loss rates? We all know the importance of bees. Bees are extremely important for our ecosystem and our agriculture. But there are some misconceptions surrounding the status of honeybee health. Honeybees are often presented as being on the verge of extinction or at least in decline. So yeah, is that true? Let's first look at population size, which is the total number of honeybee colonies in the world. Those numbers have been put together by the FAO, Food and Agriculture Organization, based on all available estimates from contributing countries. What we see here is that the total population, the total number of honeybee colonies in the world has actually been increasing since the 1960s. Now, locally, some regions of the world are showing declines in the same period of time. In the US, for example, those estimates are provided by the USDA on a yearly basis. And we see that since the 1960s, we have seen a reduction to about half of the colonies that we used to have. However, one thing that the USDA is very clear about is that the methods of counting colonies changed midway through the survey. In fact, the largest drop in the curve corresponds to that change in methods. Basically, what happened is the USDA stopped counting colonies belonging to small-scale beekeepers with less than 5 colonies due to budgetary constraints. So if we look at the period of time using that new method of counting, we now see that the decline is actually much less impressive, just 12%. And that is actually significant. That is a significant period of time for beekeepers in the US because the two largest threats to honeybees happened during this period of time. The Varroa mite was first recorded in the US in 1987, and decades later, around 2006, 2007, colony collapse disorder really frightened beekeepers by unexplained high level of colony loss. So we see in this figure that despite those two major events, the number of colonies in the US has been relatively stable, with even a slight uptick in the last 20 years or so. So going back to my question, why monitoring colony loss rates? Well, because total population size offers only half of the equation. It would be like knowing the population of a country, but not looking at its mortality rates. You can have a population growth despite a high mortality rate if the natality rate is high enough to compensate. So population growth can hide a high mortality rate. Mortality rate is what informs us about the health issues facing a population. In honeybees, we call mortality rate loss rate, but it is really equivalent. When colonies die off or when beekeepers combine two colonies into one, you effectively have lost one colony unit. On the flip side, swarming and splitting colonies is the equivalent of natality. So looking at colony mortality or loss is like looking at the turnover of colonies. How many colonies will need to be replaced because they were lost at some way during the year? And so in our survey, we asked beekeepers the number of colonies lost during a specific period of time. We typically work in 2 seasons, 6 summer months and 6 winter months every year. And here are our results. In this graph, the bars indicate the estimated loss rate for that season, winter in blue, annual in red. And so after over 10 years of surveys, we see that on an average year, about 30% of colonies will be lost during the winter, and about 40% of colonies will be lost on a calendar year. So is this abnormally high? Unfortunately, we do not have hard data to compare those rates to rates from before 2007 in the United States. However, those rates far exceed what beekeepers tell us they find acceptable. So in this figure, you can see that baseline of acceptable level in gray. Beekeepers tell us that they would find acceptable to lose between 15 to 20% of their colonies in a season, though that number has actually crept up over the years. So we do not see evidence of an increase in loss rates over time, but we are also not seeing an improvement despite huge efforts. And as I will show you in a minute, despite big changes in practices used by beekeepers. So in honeybees, we do have a case of population growth hiding a high mortality rate. And that high mortality rate is what tells us that honeybee health is hurting. For those interested in the methods, the survey is what we call a retrospective survey, meaning every year in April, respondents will give us their responses for the past 12 months. The survey is voluntary. We target all US beekeepers, and we typically receive a lot of help to try to reach as many beekeepers as we can. So large beekeeping organizations, bee journals, supply companies, numerous beekeeping clubs, and state apiary inspectors are all contributing to our outreach to spread the word. The survey is online and open for a full month. And we do conduct some phone interviews, particularly with large-scale beekeepers to try to help to fill the forms. The survey has been conducted since 2007, as scientists realized at that time that we didn't really have a great baseline on what a normal loss rate should be. We typically reach over 4,600 respondents per year, which for the US means that we are representing about 12% of the colonies in the country. Representativeness is, of course, the goal, and we are fairly confident that we represent US beekeepers well, because we can compare the structure in our respondents based on the known structure of the industry. So in the US, the Department of Agriculture runs a census of agriculture every 5 years. And they were kind enough to give us a breakdown of US beekeepers and colonies by operation type that fits our definitions. So we can compare those proportions in our survey versus the census. And we see that they were very close indeed. So this shows that we are quite successful at reaching out to beekeepers of all sizes throughout the industry. Now for background, here are our definition. In the US, we classify backyard beekeepers as those keeping between 1 and 50 colonies. And in our results, we actually see that they had a median of 3 colonies, meaning half of our backyard respondents kept between 1 and 3 colonies, and the other half kept between 4 and 50. Sideliners are classified as beekeepers keeping between 50 and 500 colonies with a median of 100. And finally, commercial beekeepers are those managing over 500 colonies they had a median of 2,000. And some of the largest US operations are known to keep over 50,000 colonies. So you can imagine that beekeepers don't manage 5 or 5,000 colonies the same way. Colonies in those very different operations will be faced with very different conditions. So it's very important that we document those conditions and the practice that are used by those very different beekeepers. And by the way, here on the left is a picture of one of our apiary on the rooftop of our university. And the student that worked in our lab a few years ago, unfortunately a little dated now. So talking about different conditions, in particular, commercial beekeeping can be very intense in the United States. Commercial colonies are our migratory pollinator force, and they're in very high demand. Which means that a large section of our commercial colonies are always on the move to pollinate crops everywhere in the country. They're also typically placed in higher density apiaries and closer to high ag environment. From our survey, we also know that beekeepers come with a wide range of experience. Now, usually small-scale beekeepers are more likely beginners, with 50% of backyard beekeepers having less than 5 years of experience. And commercial beekeepers are typically the more experienced one, with 50% of commercial beekeepers benefiting from over 37 years of experience. Without surprise, this all translates into very different levels of risk for those colonies. So in this graph, you see the loss rates. So again, lower is better. For all 3 types of operation, backyard, sideliner, and commercial, and by season as shown in color. Now in saturated colors, you have the most recent estimates from 2021. And in desaturated colors, I'm showing you the historic levels from all the previous years combined. So straight away, you can see that the annual loss rates in red is typically higher for backyard beekeepers than commercial. So despite intense beekeeping, commercial beekeepers do show lower rates of colony loss than small-scale beekeepers. Another key result is that backyard beekeepers tend to lose more colonies in the winter than in the summer, which, as we would expect in the Northern Hemisphere. However, commercial beekeepers tend to show more similar rates in summer and winter. So commercial beekeepers seem to lose colonies throughout the season rather than all at once in the winter. Now, we also have quite a high variability in the risk of colony loss geographically. We are currently working with geographs to study the spatial variation of loss in more details. And of course, this is most relevant for small-scale beekeepers, as the vast majority of large-scale beekeepers are migratory and therefore moving from state to state throughout the year. In the survey, we asked beekeepers to identify the cause of loss in their operation. So this is a beekeeper opinion, but this shows very different opinions between beekeeper types. So in this figure, the bar shows the proportion of beekeepers having selected one or the other causes of loss from a multiple choice question. And we see that commercial beekeepers in red are far more likely to identify Varroa and queen issues as the top causes of loss in their operation, far above any other reason. On the other hand, for backyard beekeepers in blue, you see that their opinion was way more divided. A good fraction identify Varroa and queen issues, but also starvation, weather conditions, and unknown causes were all cited as frequently as well. So this tells us that the perception of health issues is also variable by operation type. We all know that Varroa changed beekeeping wherever it arrived. In the US, the parasite Varroa arrived in the late 1980s. And there is a saying that before Varroa, you could be a bee haver, but now you need to be a beekeeper. And Varroa really changed how we keep bees. But what is pretty interesting is that we continue to see the change in beekeeping practices. Now, as part of the survey, we have asked what beekeepers do in terms of monitoring and control of Varroa since 2011. In this figure, I am showing you the proportion of respondents that reported using some type of Varroacide in their operation. As you can see, 10 years ago, the majority of beekeepers were not using Varroacides. But this has completely changed since. Now, we also see those waves of adoption of new practices in how beekeepers monitor for Varroa. The recommended practice in the US is to use alcohol wash, shown in the graph in yellow. And you see here how in a few years, it really became the most prevalent method used by beekeepers in the US. Of course, extension specialists always discourage the reliance on visual cues in the hive, so waiting to see mites on bees. And thankfully, we do see in our survey that the proportion of beekeepers that still rely on visual cues only, in pink on the graph, is slowly dropping. Now, if we combine the questions, do you monitor and do you treat, we can group beekeepers in 4 categories. In yellow, they don't do anything at all. In brown, they monitor but don't treat, which could be giving them the benefit of the doubt because they have verified that they didn't need treating, question mark. In light blue, they treat but don't monitor, which is not great because that probably means that they rely on calendar treatment and they don't check that the treatment actually worked. And finally, in dark blue, the recommended practice, monitor and treat. And again, we see that this recommended practice has been widely adopted by the beekeepers over time. Now, as everything else, those proportions vary according to the type of operation. And we see here that commercial beekeepers were the early adopters. And we see that we still have some work to do to spread that message in smaller bee operations. Now, the survey documented a large number of management practices covering the whole range of management that beekeepers use throughout the year, from feeding to equipment, queen replacement, disease, pest monitoring and control, honey harvesting, you name it. We used all of that data to identify among all of those practices, which ones were the most associated with colony loss. In other words, if we have to promote only a few behavior changes, what should we promote to obtain the highest level of drop in colony loss for the whole population? What change in practice should we prioritize? This was the work of my PhD, and it has been recently published. And without boring you with all the methods too much, we found the top practices that, if changed, would result in the highest reduction of colony loss. And we did this for different types of beekeepers based on their operation size and region, because if their starting practices are different, of course, the recommendation for change should be different too. Now, that work was observational based on survey data and correlation. So, of course, the next step in our public health model is, after developing those new strategies, is to test them. So came after me another PhD student, Dr. Kelly Kulhanek, who took to the field by comparing outcomes of colonies kept under either the standard array of practices or the improved practices. She monitored those cohorts for 3 years and found that indeed the improved practices were associated with reduced load and prevalence of Varroa, viruses, and also led to reducing the risk of colony mortality. Her results are also published and available if you are interested in more details. So what were those top recommended practices? They were mostly linked with Varroa practices. We recommend to treat based on action thresholds, and that was as compared to the prevalent practices, which is treating based on calendar dates and not on actual infestation numbers from your own colonies. We also recommended that beekeepers visit their apiaries regularly to try to catch dwindling colonies early and combine them so that the equipment is not left unattended too long. Now, if comb is left unattended, we recommended those frames to be frozen before reuse or not reusing them at all. And finally, we also found that starting new colonies from packages is associated with higher failure than from nucleus colonies. Though we do not recommend it against using packages, we do caution beekeepers that those colonies will require more surveillance. Finally, our field studies show that improved practices do not have a result overnight. Those differences between the two groups really increased year after year. So if you do changes practices in your operation, you have to be patient to see the results. You know, it's like when you start to exercise again after 2 years of staying indoor, it's going to take time. So the biggest takeaway we had for both small scale and large scale operation was that monitoring was key. Monitoring for pests should be the core of your practice, and it should dictate if and when you use a treatment, and it should be used after treating to see if the treatment was effective and to catch any potential reinfestation from neighboring colonies. If you want more information about our organization and our data, you can find it online. I thank you for your attention, and I would like to take a second to thank all of our collaborators and sponsors. So thank you for inviting me to speak, and I will look forward to answering any question you have.